Hello class, welcome to the week 9 unit. And during the course of this unit, we're going to be talking about some other tidbits that sort of extend upon what we talked about in the week 7 unit. One of which is going to take more of a detailed look at multidimensional data sets and also introduce a new type of data type that we can work with, which is called an array. Uh, the arrays are a little bit different than lists, and we're actually going to highlight those differences in this video. And in the next segment, we'll actually take a look at how to set arrays up in Python. But another thing that we're going to talk about during the course of this week, well, a couple other things. One is how to actually plot information onto a graphic, and we'll just talk about that when we get to it in greater detail, but we'll just give sort of a brief introduction on how to go about that and how to use the appropriate Python module to accomplish that. And another thing which sort of extends on the idea of multidimensional data is the idea of a nested for loop, and that'll be a topic that we conclude the weekly unit with. But to start things off, let's go ahead and dive right into this first segment and introduce the idea of an array and highlight some of the differences between arrays and lists. The two are very similar, but there are some subtle differences, and those subtle differences can actually be quite advantageous when we're working with data sets, especially numerical data sets. So let's just go ahead and make a table that will sort of compare and contrast Python lists and Python arrays. So one thing that we should note is whenever you had a Python list, you could actually put multiple different data types inside the Python list. That is, in a Python list, you could have entries in the Python list that are numerical, and you could also have entries in the same Python list that are textual or maybe some other data type. In the case of arrays, every single entry in the array must be the same data type. That is, if you have an array that's holding onto numerical data, then every single entry in that array must be a number. It must be some sort of numerical value. If you've got an array of textual data, then every single entry in that array must be some sort of textual value. It must be a string of some kind. So lists, you can put different data types. You can say mix textual and numerical entries inside of a Python list, but you cannot do the same thing for arrays. Arrays have to have all the same data type. That is, everything has to be numerical, or everything has to be textual, or everything has to be whatever data type you might be working with. And another difference between lists and arrays, we've sort of taken a look at this in previous units, how we can add items to a list or we can append items to a list, which means that lists, you can change the length of the list, you can change the number of entries in the list even after the list has already been declared. Unfortunately, you cannot do this with arrays. Once you've declared the array, however many items are in the array, that's how many items are going to stay in the array. So if you declare an array that has 5 items in it, then that array will always have 5 items in it. You cannot add items to the array. There is a way to sort of work around that, but it involves some trickery. But for now, the one thing I want to emphasize is if you're working with an array, you cannot add items to the array. But if you're working with something that is a list, then you can add items to that list. You can change the number of items in that list, but the same does not hold true if you're working with an array. If you're dealing with a one-dimensional list, excuse me, if you're dealing with a one-dimensional list, this kind of goes back to what we looked at in week 5. If we want to pull a specific entry out of that list, then we just simply type the name of the list in question, followed by a set of brackets, and then we put a 0 in there to say we want entry number 0, which is what we humans would call the very first entry. And just like with arrays, the computer starts counting at 0. And the way you access one-dimensional data is pretty much identical. You simply type the name of the array followed by a set of brackets, and then you put the number in the brackets that tells the computer which item you're interested in. And just like with lists, the computer starts counting at 0. So what we humans would call the first entry in the array, the computer would call entry number 0. So hence the 0 in the brackets here. Now things become a little bit more interesting when you start working with multidimensional data. So we introduced the idea of a two-dimensional Python list in week 7, and we looked at how we can pull individual entries out. Excuse me, pull individual entries out of that two-dimensional Python list. And we saw that we needed 2 sets of brackets, and the number that we put in the first set of brackets corresponds to a specific row. Remember, we wrote the two-dimensional Python list in terms of rows and columns. The number that we put in the first set of brackets is the row that we're interested in, and the number that we put in the second set of brackets is the specific column that we're interested in. The nomenclature is pretty similar to an array, but there's a very subtle and very important difference that we want to highlight. Excuse me, for some reason my voice doesn't want to work this morning. There is a very subtle difference here. Instead of having multiple sets of brackets like we do in the list, so you see we have multiple sets of brackets, in the case of an array, we have one set of brackets and the individual dimension is separated by a comma. Now the order is still the same. So this first number in this first set of brackets is still the row number. And this first number to the left-hand side of the comma is also the row number. And the number on the second set of brackets is a column number. And this second number to the right of the comma here is still the column number. So it is still row number first, column number second, except in the case of an array, we use just one set of brackets, row number, comma, column number, and that pulls the individual entry out that we want. So in this case, this would be row number 0, column number 0, whatever that entry is, pull it out, and then do whatever with it. And if you're working with something that's three-dimensional, so if you had, say, a three-dimensional Python list, then you would have three sets of brackets. And when we start working with three-dimensional data, it actually becomes helpful to think of this in terms of stacks, rows, and columns. And you'll see what exactly I mean by that in the next segment or some later segment. And the way that we'll see this works is we go stack number for when we have three sets of brackets, we have stack number, then row number, then column number. So again, three sets of brackets, one for each dimension. In the case of an array, we still have one set of brackets, but the order is pretty much the same. We still have stack number, then we have comma, row number, then comma, column number. So again, the main difference here is we have a set of brackets, a pair of brackets for each dimension that we have in our list. In the case of an array, we have one set of brackets, and then we have one number for each dimension inside of our array. And again, the order goes stack number, comma, row number, comma, column number. So subtle difference, but a very important difference to keep in mind. If you're working with an array, you should have just one set of brackets. So notice the one set of brackets here, and the individual dimensions are separated by commas, as opposed to a list where the individual dimensions each get their own set of brackets. That is not the case for an array. Now, the advantages that arrays offer will become very apparent here when we actually start exploring the following topics. So in the case of a list, if you try to add two lists together, the computer will not add the individual components together. It will in fact perform a concatenation and join the two lists together in the order that they appear to form a longer list. In the case of an array will not do this. An array will actually add each individual component together, and the end result will be an array that is the same length as the original two arrays. And one of the restrictions that we'll highlight and emphasize and put greater emphasis on in the later segment is whenever you're doing some sort of math between arrays, the individual arrays must be the same shape and they must have the same number of dimensions, and they must have because for instance, if you have like a 4x2 array and a 2x4 array, you can't add those two things together. So the dimensions have to be the same and the shape has to be the same. So in this case, we just have a very simple array here, each with one entry, and that's perfectly fine. We cannot, however, take an array with 2 items and an array of 3 items. We can't add those together. But again, we'll talk about that in greater detail a little bit later on. Subtraction. If you try to subtract one list from another, you'll get a lovely error message, and that's something that we kind of alluded to when we were discussing the week 5 material. But in the case of an array, as long as the array is holding on to a numerical value, that is perfectly fine. Just like with the addition, each corresponding component is subtracted from the other, and the end result will be an array that is the same number of items as the original two arrays that we started with. Multiplication. So whenever we had a Python list and we were multiplying that by some integer, again, that is not going to distribute the 2 to each individual entry in the list. It is in fact going to concatenate the list to itself this many number of times, whatever this number might be. However, in the case of an array, it will actually distribute this 2 to each individual entry in the array. So here we have the same list of numbers, or the same array of numbers that we have over here, except here when we multiply this, when we take the asterisk by 2 here, this will in fact multiply each individual component in the array by 2, so the end result will just be, in this case, 2 comma 2, just simply distributing this 2 to each of an individual entry in the array. And sort of an extension on that, if you're trying to multiply 2 lists together, this will give you an error message, but if you multiply 2 arrays together, again, each individual component will just be multiplied together to get the result for the new component in the new array. So in this case, we have this array with two entries, 1 comma 2, this array with two entries, 3 comma 4. So the end result will be an array that has the same number of items, and in this case the first item will be the 1 multiplied by the 3, which is a 3, and this 2 multiplied by this 4 to get this 8. So you can see how each corresponding component is multiplied together to get the result of the new component. So in this case, the 1 by the 3 to get the 3, and the 2 multiplied by the 4 to get the 8. And division also works with arrays but does not work with lists. So if you try to take one list and divide it by the other, you will get an error message. But if you take one array and divide it by the other, then again, it will perform that math component-wise. So each corresponding component is divided by the other to get the result of the new array here. But that's going to do it for this introduction on lists versus arrays. And in the next segment, we're going to take a look at how we can actually use arrays in our Python programs. So with that, I will see you all in the next segment.